This is the Chemistry 121 lab safety video for analysis of hard water. People who live in certain regions of the country, such as the Midwest, are very familiar with hard water. Hard water contains a higher than normal concentration of calcium and magnesium ions. These ions form precipitates or solids with soap, causing the formation of soap scum that has to be scrubbed to be removed. In this lab, you'll be experimentally determining the hardness of two samples of water using a method called titration. Titration involves adding a precise amount of a known substance using this piece of glassware called a burette. You will add your known substance to an unknown solution where you don't know the molarity. Also in this flask is an indicator that changes color at the end of the experiment. In this experiment, you will also be using a buffer that contains a corrosive chemical, so safety goggles should be worn at all times. Caustic or corrosive chemicals will damage your skin, so care should be used when handling these chemicals. If the buffer does come in contact with your skin, rinse your skin with water immediately. The titration in this lab will allow you to add a precise amount of 0.01 molar ethylene diamine tetraacetic acid disodium salt, or EDTA for short. This EDTA will react with all of the calcium cation that is in your sample of hard water. We'll be adding our EDTA, the burette, and our calcium solution, where we don't know the molarity, to the flask. When the moles of EDTA that we have added to the sample of hard water are equal to the moles of calcium cation in the sample, the indicator that we add will change color, and we will have reached what is called the endpoint. From the known concentrations and volume of EDTA added, you'll be able to calculate the concentration of calcium cation in the hard water sample. For this titration, the EDTA, or the titrant, will be measured using this burette that allows us to precisely measure how much we have added. We'll measure our initial volume that's in the burette to begin with. At the end of our experiment, we'll measure the final volume. If we take the difference between the final and the initial volumes, we'll be able to calculate how much EDTA we added. Before you begin your titration, rinse the burette with deionized water, and then with EDTA to remove any contamination. Then carefully add EDTA to the burette using a funnel until you reach the top. It does not have to be at exactly 0.0 milliliters at the top, just between 0 and 5. You'll then rinse the Erlenmeyer flask with deionized water to remove any contamination, and to this clean flask, you'll add 20 milliliters of your hard water sample, 6 drops of your indicator, and an entire dropper full of buffer. In order to make the color change easier to see, add about 20 milliliters of deionized water to increase the volume of the sample without changing the number of moles of calcium cation that are present. Record your initial volume in the titration, and then slowly add EDTA by turning the stopcock and gently swirling the flask. Continue to slowly add EDTA until the indicator begins to change color. Then add EDTA slowly, 1 drop at a time, until the color change persists for 10 seconds or more. Then record the final volume. You will complete 3 trials for the titration using new samples of the same unknown solution. In addition to determining the hardness of an unknown sample, you will also be performing a titration on your own sample of water to determine its hardness. Prepare for lab by bringing approximately 100 milliliters of water from home or work, a pond or lake, a restaurant, etc., something that you want to test the hardness of. After the lab is complete, all liquid waste should be disposed of in the waste bucket in the fume hood. Chemicals should never be poured down the drain. The only substance that can be poured down the drain is tap water or pure deionized water. Before you leave, make sure you clean, dry, and put all equipment back where you found it, whether it's your box, a cart, or a drawer in the lab room. Wipe off your lab bench and wash your hands. I'm now going to explain the calculations necessary for your titration. The calculations for this titration are 3-step. You'll begin by determining the moles of EDTA that you've added from your burette. To do that, you'll take the concentration or the molarity of EDTA multiply it by the volume of EDTA you needed to add. That will give you the moles of EDTA that were added to your experiment. Step 2 is determining the moles of calcium 2+ that are present. You'll take the moles of EDTA you determined from step 1, and then use a mole ratio from your balanced chemical equation to calculate how many moles of calcium were present in the flask. Once you know how many moles of calcium, calculating the molarity, or step 3, is just a matter of taking the moles of calcium that you calculated and dividing by the liters of calcium solution that you added initially to your flask. And that's all there is to a titration.